accept here in the default, then you might have a mismatch of your process ID and your file descriptor.
That is true.
I tested that in mine because I had a problem where it wasn't necessarily connecting in order. So I just made a very, very basic bind, connect, accept, listen, and they don't necessarily connect in order.
Yep.
I had mine just send their PID along with their connect call, and then they matched the PID to a PID it started already, and then it
So
knows
you have
which
to
file
match.
descriptor goes with which PID.
But the funny thing is, I never really encountered the symptom of that bug. I'm pretty sure the bug is here because that's exactly what I did. I decoupled the creation of the child processes from the accept calls that would actually put the socket file descriptor into the structure. But for some reason, it did not actually show up as a bug. So maybe it's just because of the chance of that type of misordering did not happen in
Well,
this
mine
case.
connected out of order too, and I didn't have mine didn't show up as a bug when I killed mine either.
Okay.
But
But that's a very good point. That's a really, really good point. So this solution is not entirely correct. It's just that it's hard to create the scenario that will make the bug show up, as a mismatch. This part here has to do with handling the signal in the SIGINT. This will be on the client side, so the client function has to set up the handler for the SIGINT signal. And the signal handler doesn't really do anything that's really useful. All it does is to print to standard error and say client blah is about to die, and this one will change to client num plus 1 later on, because of the orientation of 0 versus 1. And then it will specify the old action for the signal handler. The old signal handler, it will change it back to the old signal handler, and then it will raise the signal again to kill itself.
Can't you just use SIG default? Or does
Yes, you can. Yep. But this way is more scalable, just in case someone else actually had a signal handler also before this one, so it's, as per the notes, this is the more flexible way. But yes, if you know for sure that you only have one custom handler that you have specified so far, you can just go back to default. And then it's just one little block here that handles, how to specify the signal handler. And I think that should be it for the most part. I added one option to deal with automatic mode. So automatic mode is actually the default now. So when I just type /socket4, it will automatically run in automatic mode, unless you specify server and or client. Then it will switch back to the independent mode. And here's the embarrassing part. I did not fix it here. I was probably just playing with it when I specify ignore, SIGKILL, SIGINT, and so on and so forth. So it wasn't working. Because when I specify these two are, this one is needed. Okay, you need that one to handle the case when the pipe is broken. The second one doesn't really do anything because you cannot ignore kill. The third one, threw a wrench into this whole program because I was ignoring SIGINT, and that's not going to be very helpful because when I restore to the previous signal handler, it would just restore to ignore. So the message will print out on the screen, client block is about to die, and then it does not.
Nice
And that's
one,
because I
Pat.
was just playing with it, right? So that's embarrassing. It's good to have those moments. Okay, so this is comparing the second last to the current version. And the change should be fairly minor at this point.
So your client, when it receives that SIGINT, it doesn't, it just dies right away, it doesn't close the file descriptors or anything like that, no cleanup?
No cleanup.
So the server doesn't really have any idea that it's closed except for that wait PID?
The server would actually close the connection first, and then it will send the signal to kill it.
So the server closes that file descriptor?
Yeah. And this one, let's see, the changes is, okay, so the server doesn't, okay, in this case, the server, I think it's at the client or the server. This is actually on the client side. So the client will no longer say that the server has closed the connection and therefore I have to die. It will just keep going and going and going, and it will just wait for the signal to get itself killed. Okay, so which is as per the instruction. And as I said here, the message has to add 1 to it because we want to look at client 1, 2, and 3 and not 0, 1, and 2. And then fix these two, take out the signal call to ignore sigint, so that the program would actually die when it reverts back to the previous handler. And that was it.
So did you say your server receives a SIGINT too?
No,
Your server dies normally?
the server does not specify how to handle SIGINT, which means it will terminate when it receives SIGINT.
Oh, but the server does receive a SIGINT?
No,
Oh, okay.
should not,
Yeah.
unless you send it from somewhere else.
I thought you said that. I didn't send mine.
Okay, yep, there's no need to do it. I don't think the homework assignment specifies whether the server has to handle SIGINT in a different way or not. So, okay, so now what I want to just show you guys where the bug is, because that was a very good point that the file descriptor is no longer associated with it. Delete, and then we go to the connect call, accept. So the accept call is the issue here. It is in the loop. Okay, so this is the loop to deal with all the clients. If it's in the automatic mode, it will first create the process. And after it creates the process, later on it does the accept call down here. Where's the accept? I cannot see, I cannot read.
2 lines up.
Right here. So then it will accept it will perform the accept call, and it still does not guarantee that it will be the client that I just created. Well, let's see. Yes, it does. It has to be in that order.
It doesn't necessarily, because the clients won't necessarily connect in order. They'll probably connect in reverse order. When you fork and then fork immediately again, the first.
But you don't fork
process-
again. You don't fork until this one is accepted already.
Oh, you accept in the loop?
In the same loop,
Oh,
yes.
that's what I did.
Okay.
I thought you didn't.
I thought I did not either.
Yeah, 'cause if you don't.
I cannot
then you get
remember what I
mismatch.
did at about 3 o'clock.
Because that caused a huge problem in my program. You get a mismatch sometimes.
Yeah, I didn't.
Correct.
When I first did it,
So no wonder that never happened to me, because it's actually in the same loop, and there's no way it can be out of order if I did it
They're
this
in the
way.
same loop, yeah.
Right. Yep, go ahead.
I didn't connect in the same loop when the first time I did it, so. that's-
So you have some mismatching problems? Okay.
But it worked fine.
You'll see if you run it a lot of times though,
Mhm.
you'll start to see,
It depends on the load, depends on the timing. So you have basically it's called a race condition. It's a fairly common problem with multi-threaded or multi-processes, or solutions that have multiple processes or multiple threads. Is a race condition. So in most cases, the problem is in most cases if the race let's say you have A and B, okay, and the race condition is whether A or B can get to this point first. It is not a bad thing when it's 50-50%, because you will see that symptom happening at some point, okay? You test it once, you test it twice, the second time it will fail if it's 50-50%. The problem is when the race condition is, A will get to the destination first 99% of the time, and B will get to it like 1% of the time. Then you have a real problem when you have to debug or test that code, because you test it 50 times and guess what? You don't see